What if Mars is not the barren wasteland we have long imagined? What if beneath its endless sands it has hidden a secret all along? The red planet stands in silence, a world carved by storms older than humanity itself. Its horizon stretches into infinity, a desert of stone and dust where the wind sculpts mountains and buries craters in shifting shadows. To the human eye, it seems lifeless, cold, forgotten. Yet every grain of sand carries the memory of a world that once breathed differently. For decades, Mars has been a mirror for human curiosity. Telescopes revealed its deserts. Orbiters mapped its valleys and canyons. Rovers pressed their wheels into its soil, each mission peeling back another layer of its story. But in 2021, a new traveler touched down upon its rusty plains, a machine of quiet resolve. China's Zhurong rover, part of the Tianwen-1 mission, rolled across Utopia Planitia, a basin so vast it could swallow continents. At first, it was only meant to search for patterns in rock and soil, to measure the whispers of wind, to taste the chemical echoes of a planet that once held water. Yet what it uncovered stirred a deeper question. Beneath layers of sand, signs began to emerge, patterns of movement, traces of something that defied the long-held belief that Mars had been frozen in silence for millions of years. The dust seemed to shift not only with the wind, but with time itself. And in that mystery, Mars spoke again. In the spring of 2021, a new sound touched the silence of Mars. It was not the hum of American machines or the orbit of European satellites. It was the quiet mechanical breath of a traveler from the east. China's Tianwen-1 mission had crossed interplanetary space and delivered its emissary, the Zhurong rover, to the red plains of Utopia Planitia. Utopia, a name given by Earth's imagination to the largest known impact basin in the solar system. An ocean basin of rock so wide it could drown continents, so ancient it holds the memory of Mars when it was still a young and restless world. Here, Zhurong descended, cradled by parachute and retro-thruster, until its 6 wheels pressed into the Martian dust. For the first time in history, another nation had placed its own witness on the surface of the red planet. The rover stood small against the immensity of the desert. Its solar panels unfolded like wings of a mechanical insect, catching the pale sunlight that filtered through thin skies. On its back, it carried instruments born of quiet precision, high-resolution cameras to scan the horizon, sensors to taste the chemistry of soil and stone, a magnetometer to listen for whispers of the ancient field Mars had long since lost. And most remarkable of all, a ground-penetrating radar, a tool capable of peering beneath the visible world, down into the buried layers of Martian time. Other rovers had read the surface, pressing their eyes close to scattered rocks, searching for the fingerprints of water. Zhurong was different. It would listen to what lay beneath. Each pulse of radar was a question cast into the unseen, a probe into the silence below the dunes. What it returned was not emptiness, but echoes. Reflections layered like pages in a forgotten book. At shallow depths, the radar revealed patterns of stratigraphy, alternating bands that hinted at shifting dunes laid down in cycles. Wind had sculpted the desert, yes, but something more had moved here. Some layers bore signatures that seemed finer, more compact, as if shaped not only by air but by the slow settling of water. In places, the echoes deepened further, suggesting buried structures that resembled shorelines or lake beds now entombed in dust. To planetary scientists, this was a revelation that carried weight. For decades, Mars had told fragments of its story. Viking in the 1970s glimpsed a world carved by channels yet dry as bone. Pathfinder, Spirit, and Opportunity traced the scars of ancient floods and measured minerals that could only form in the presence of water. Curiosity, roaming Gale Crater, drilled into clays that spoke of long-vanished lakes. Perseverance at Zhurong now gathers samples in a crater delta built by rivers that once flowed with persistence. Each mission had been a step forward, an eye turned to a different horizon. But Zhurong was listening from beneath. It was as though Mars had been whispering its story above ground for decades, and now, for the first time, the sands themselves were unsealing their archive. The layered echoes hinted at epochs of change. Dunes advancing, dunes retreating, water seeping, then vanishing. Perhaps ancient lakes filling Utopia Planitia before retreating into silence. The cycles recorded below the rover's wheels suggested a planet not frozen into one fate, but restless, oscillating between extremes. For scientists, this complexity matters. If the ground records not only wind but water, then Mars may have remained habitable far longer than once believed. Pockets of brine could have persisted beneath the soil, shielded from ultraviolet radiation by layers of dust. Microbial life, if it ever began, may have found shelter there in the deep recesses of the planet's memory. The discovery was not loud. It was not a headline of fossils or flowing rivers. Instead, it was a whisper, a subtle revelation buried in stratigraphy. Yet in science, whispers often carry the weight of revolutions. Zhurong's journey was brief compared to its American counterparts. After a little more than a year, the rover fell silent, succumbing to the cold grip of Martian winter and the veil of dust that dimmed its solar wings. But in that short span, it changed the conversation. Its radar had written a new chapter in the study of Mars, one that could not be told from orbit or from surface images alone. The echoes beneath Utopia Planitia suggest that Mars is not a dead archive of a single past, but a layered palimpsest of shifting climates, each stratum preserving traces of a world in motion, a world that may have carried water long after humanity thought it gone. In the silence of Mars, the rover's voice has faded, but the record it left endures, a map of hidden structures waiting to be deciphered. Zhurong became more than a machine. It became a reminder that Mars is still full of secrets, and that the planet yields them only to those who are willing to listen beneath the surface. For generations, the story of Mars seemed certain. It was the tale of a young planet that once flowed with rivers, filled basins with seas, and perhaps even cradled the chemistry of life. But that age, scientists believed, ended billions of years ago. The Martian atmosphere thinned, its magnetic shield collapsed, and the waters that once traced its valleys escaped into space, or froze in silence beneath its surface. Mars, the textbooks declared, was a relic, a fossil of habitability locked in ancient time. That belief, so deeply woven into planetary science, now trembles. The reason lies just a few meters beneath Utopia Planitia. When Zhurong began sending back radar echoes, the data at first seemed subtle. Layers. Thin, alternating bands just below the dusty crust. But within those bands were patterns that defied expectation. These were not the deep scars of an ancient ocean billions of years old. They were young, geologically young, formed not in the primordial age of Mars, but in the recent past, within the last few 100 million years, perhaps even less. The radar spoke of stratified layers shaped by repeated episodes of change. Some bore the loose textures of dunes sculpted by shifting winds. Others hinted at compaction, denser forms suggestive of water's hand, perhaps transient lakes or the settling of brines. The alternation implied cycles, dry periods broken by wetter intervals, climate swinging not once but again and again. This was the shock. Mars was not meant to be so restless. For decades, orbital climate models painted the red planet as locked into deep freeze since the loss of its protective magnetosphere billions of years ago. Without that shield, the solar wind stripped the air, leaving an atmosphere too thin to sustain long-term liquid water. Under such conditions, Mars should have become static, its desert landscapes unchanging except for the erosion of wind and dust. Yet the layered echoes beneath Zhurong's wheels whispered a different reality. They spoke of oscillations, climate shifts in the late Amazonian period, Mars's most recent geological epoch. An epoch thought to be marked only by cold stability, by the grinding persistence of dust storms and the freezing of polar caps. Instead, the ground revealed evidence of pulses, warmth, moisture. Episodes where the planet reawakened, at least briefly, to dynamics once thought lost forever. For scientists, this revelation is as unsettling as it is thrilling. If Mars experienced such changes in the geologically recent past, it implies that its climate is not only a story of ancient loss, but also of resilience and recurrence. Perhaps Mars is more like Earth than once imagined, subject to cycles, to shifts driven by the tilt of its axis, the shape of its orbit, or the waxing and waning of its polar caps. Planetary scientists point to obliquity as one of the key suspects. Unlike Earth, stabilized by its large moon, Mars wobbles. Its axial tilt can swing dramatically, from near vertical to steep angles over timescales of hundreds of thousands to millions of years. Such swings transform the planet's climate. Ice at the poles can sublimate, water vapor can spread across latitudes, and transient periods of warmth may ignite processes of erosion, deposition, and even liquid flow. If Zhurong's radar is capturing the fingerprints of those cycles, then Mars has not been entirely dormant. It has been breathing in deep time, shifting between slumber and brief awakenings. The implications stretch beyond climate. If the red planet has been periodically active in the recent past, then the window for habitability may not have closed billions of years ago. Subsurface brines, periodically recharged, could have endured far longer than models suggested. Microbial life, if it ever gained a foothold, might not be confined to a distant epoch. It could still linger in sheltered pockets, protected from radiation by overlying sediments, nourished by periodic pulses of moisture. The shock lies not only in what was found, but in how near it lies to the surface. These layers were detected just a handful of meters beneath the rover's wheels. Such proximity means the processes that shape them are not remote in time. They are recent enough to be preserved in fragile sediments, unobliterated by the relentless winds. They are close enough that future missions could reach them, sample them, and read their chemistry directly. For decades, the search for life on Mars has focused on places of ancient water, billion-year-old deltas, fossilized riverbeds, and clay deposits that formed in epochs when the planet was young. But Zhurong's discovery shifts the gaze. It suggests that Mars's more recent chapters may be equally important. That in the late Amazonian, against all expectations, Mars still had the capacity to change. Such a revelation unsettles the human imagination. We are accustomed to thinking of worlds as static categories. Earth, the living planet. Mars, the dead planet. Yet the ground beneath Utopia Planitia refuses to fit such binaries. It tells of a planet that is neither fully alive nor entirely dead. A planet that drifts in between, carrying remnants of vitality into epochs where none were supposed to remain. In the silence of that Martian desert, the echoes of layered stratigraphy force a philosophical reckoning. If Mars can hold secrets so close to its surface, what else lies hidden deeper? What if the story of habitability is not a straight line into oblivion, but a fractured narrative, full of pauses, resurgences, and unexpected turns? Science thrives on such moments of disruption. When data refuses to conform, when a machine whispers from another world that the universe is more complicated than we thought. Zhurong did not send back images of Martian oceans, nor proof of organisms clinging to life. What it sent was something subtler.
Yet in its subtlety, it may be more profound.
It showed that Mars is not the static tomb we assumed. It is a planet with a pulse. For those who dream of exploration, this shock changes the map of possibility. If Mars is more dynamic, then the search for life gains new terrain. Future rovers and landers may not need to dig into billion-year-old rocks alone. They may find answers just beneath the dunes and sediments shaped by cycles far younger, perhaps even overlapping with the emergence of human civilization on Earth. The legacy of Zhurong is therefore not only technical, not only geopolitical. It is existential. It reminds humanity that even in its apparent stillness, Mars continues to surprise. That planets, like living beings, carry depths of complexity unseen at first glance. In a few years, Zhurong's voice fell silent, its solar panels buried by dust and its circuits frozen by the cold. Yet its message endures. Mars has not surrendered all its secrets. Some of its most startling truths lie only meters beneath its skin, waiting for those who dare to listen. The shock of discovery is not only scientific, it is also human. It challenges our assumptions, humbles our certainty, and deepens the mystery of our cosmic neighbor. For every answer the rover has given, it has unfolded new questions. How often did Mars breathe with these cycles? How long did they last? And could some corner of that restless desert still harbor life, unseen beneath the sands? The silence of Utopia Planitia carries no direct reply. But in that silence, humanity now hears possibility. Science is rarely a single voice. It is a chorus. And on Mars, that chorus has been growing for decades. Zhurong's quiet radar echoes are not the only signals to rise from the red planet. Before its wheels touched the sands of Utopia Planitia, other instruments had already tried to pierce beneath the crust. From orbit, NASA's Mars Reconnaissance Orbiter carried SHARED, a radar designed to look deep below the surface. The European Mars Express brought MARSIS, another radar probing the Martian underworld. Together, they revealed vast buried structures, polar caps layered like rings of a tree, sediments in basins, and even mysterious signals beneath the southern pole that some interpreted as liquid water. Yet these were voices from high above. Their resolution blurred, their images broad and sweeping. Zhurong brought the perspective of touch. Its radar traced details only meters beneath its wheels, scales invisible to the great arcs of orbital instruments. Where SHARED and MARSIS sketched the architecture of glaciers and basins, Zhurong revealed the finer weave of dunes, sediments, and layers whispering of processes still young. As the rover pressed forward, its cameras painted a landscape that seemed ordinary at first glance. Dunes rippling across a plain, rocks scattered in silence. Yet the patterns held significance. Polygonal terrain stretched in places across the desert, networks of cracks shaped not only by wind, but by cycles of freezing and thawing. Such polygons are common in permafrost on Earth, where buried ice expands and contracts, reshaping the ground above it. Their presence in Utopia suggested that water, at least in frozen form, had played a role in shaping the land far more recently than expected. In the rocks themselves, unusual layers appeared. Some stones seemed fractured, cemented, then fractured again as though water had seeped through, depositing minerals before vanishing once more. Sediments showed signs of repeated episodes of deposition, not a single ancient flood, but pulses of activity. The Martian surface, once believed to be static, instead appeared as a palimpsest. Each layer a line of poetry, written, erased, and rewritten by forces still incompletely understood. The minerals strengthened the case. Instruments aboard orbiters and rovers alike have detected salt-rich deposits scattered across Mars. Perchlorates, sulfates, and chlorides mark places where water once concentrated and then evaporated. Such salts are more than relics. They have properties that allow them to trap water, preserving it against evaporation even in the thin Martian air. On Earth, similar minerals can shelter microbial life in extreme deserts, locking away tiny reservoirs of moisture. On Mars, their presence may serve as a quiet archive of habitability, a memory of brines that persisted longer than the planet's fading atmosphere should have allowed. When viewed together, the story deepens. Zhurong's layered radar echoes align with a broader tapestry of discovery. Perseverance, far away in Jezero Crater, now studies an ancient delta built by rivers that once fed a lake. The sediments reveal that water lingered there long enough to lay down clay minerals and carbonates, rocks that could preserve organic molecules. Curiosity in Gale Crater has drilled into the flanks of Mount Sharp, reading layers of mudstones and sandstones that tell of a lake system that lasted for millions of years. Each rover writes a chapter from its own vantage point. Alone, each is incomplete. Together, they form a chorus, and Zhurong's voice strengthens that chorus by pushing the timeline closer to the present. While curiosity and perseverance explore epochs billions of years old, Zhurong speaks of climate changes in the geologically recent past. The juxtaposition unsettles. If Chiziro and Gale testify to Mars's ancient wet youth, Utopia hints at its restless adolescence, a planet that may have kept changing long after it was thought still. Glaciers are one possibility. Mars is known to carry buried ice beneath its surface, not only in the polar caps but in mid-latitudes. Radar from orbit has mapped deposits tens to hundreds of meters thick, sometimes hidden beneath a veneer of dust. As Mars tilts on its axis, ice migrates, sublimating from one region and condensing in another. Over time, these cycles could leave the layered structures Zhurong now reveals. Groundwater is another. Though Mars today seems dry, evidence exists that subsurface aquifers may have persisted in the late Amazonian. Seepage, brine flow, or episodic floods could have shaped sediments in ways now visible only through radar echoes. The polygonal terrain suggests freeze-thaw cycles pointing to ice near the surface, perhaps periodically melting into liquid during times of higher obliquity. The deeper the data is compared, the more the picture emerges of a planet that is not frozen into permanence, but dynamic. Its deserts are not inert, but sculpted by shifting climates. Its rocks are not mere fossils, but participants in cycles of water, ice, and salt. Mars is revealed not as a monolith of loss, but as a world still wrestling with change. For scientists, this changes not only how Mars is understood, but how it is explored. The case for habitability becomes richer. If the sediments of Jezero preserve traces of ancient biology, then the salt-rich layers beneath Utopia may preserve chemistry from more recent ages. If life ever gained a foothold, its persistence may not depend only on ancient seas, but on hidden brines that endured long after. In this deeper investigation, the boundaries between missions blur. NASA's orbiters, Europe's instruments, China's rover, each thread is woven into a fabric larger than any single nation. Mars reveals its story slowly, piece by piece, to all who listen. The revelation is not of one discovery, but of a convergence. Polygonal terrains hinting at ice, rock layers speaking of deposition, salts holding the memory of water, radar echoes telling of cycles. Together they form a picture of a planet still capable of surprise. The meaning reaches beyond geology. It touches philosophy. If Mars has been active more recently, then our assumption of lifelessness grows less certain. Life does not demand oceans. On Earth, microbes inhabit salt flats, polar deserts, and subglacial lakes. They endure in brines toxic to most organisms, feeding on minerals in silence. If similar environments existed on Mars even in its recent past, then the possibility of survival lingers. The deeper one looks, the less Mars appears to be a closed book. Its pages are still turning, its chapters incomplete. Zhurong's radar joins charade, Mars's curiosity, perseverance, and all the voices before. Each adds nuance to a narrative that resists simplicity. Mars is not dead, not alive. It is in between, restless, waiting. And for humanity, that is the greatest shock of all. For the closer the story is examined, the more it suggests that Mars is not only a relic of what once was, it may be a mirror of what still could be. For centuries, humanity gazed at Mars and imagined its past. Rivers that carved valleys, oceans that once shimmered beneath a thicker sky, a time when the planet breathed with warmth and water. But Zhurong's findings sharpen the mystery in a way no one expected. The radar echoes beneath Utopia Planitia do not simply speak of ancient epochs. They whisper of change within the last 400,000 years. On the scale of planetary time, that is almost yesterday. Earth itself has cycled through ice ages in that span. Human ancestors painted on cave walls, hunted across grasslands, and began shaping tools while these Martian layers were forming. In the deep silence of Mars, climate was still shifting, dunes advancing and retreating, ice perhaps migrating, and water seeping into transient reservoirs. The revelation unsettles. For if Mars was active so recently, then its habitability may not belong solely to the distant past. Buried beneath layers of dust and sand, protected from the punishing ultraviolet light and cosmic radiation that scour the surface, conditions may have remained favorable for life far longer than once believed. Subsurface habitability is no longer a distant speculation. Zhurong's radar revealed what had always been hidden, that the shallow crust is not uniform or lifeless, but layered and complex, holding the traces of processes that may have allowed water to persist. On Earth, the deep biosphere is teeming with life. Microbes live kilometers below the surface, feeding on minerals, enduring without sunlight, thriving in conditions that seem hostile to everything else. If Earth's crust can shelter life in such extremity, what might Mars's shallow layers conceal? The possibility is no longer confined to billion-year-old lakes long since evaporated. Instead, the question extends into a nearer horizon. Could microbial ecosystems have survived into these younger epochs, nourished by periodic pulses of brine, persisting in niches shielded from the desolation above? This idea is not only scientific but deeply philosophical. Mars was thought to have crossed a threshold from youth to death billions of years ago. Yet Zhurong's discovery blurs that boundary. The planet's silence may not be absolute. It may be the silence of a body still turning, still restless, carrying rhythms imperceptible until now. For human exploration, the implications are profound. If ice or water lies only meters beneath the soil, then Mars is more accessible than imagined. Future colonists may not need to haul water across interplanetary space. They could dig, drill, and melt what is already there. The planet, once seen as a desert without mercy, could hold within its crust the very resource needed to sustain life. Hidden ice sheets, preserved reservoirs, brines trapped in salt-rich layers, all waiting beneath the thin veneer of dust. Yet with opportunity comes caution. If Mars still harbors conditions favorable to microbes, then any human presence risks disturbing an ecosystem older than civilization itself. Planetary protection becomes not a formality, but a moral question. Would humanity contaminate what might be the last untouched biosphere in the solar system? Or would it carefully learn, preserving Mars as both a home for science and a potential sanctuary for life not of Earth? The radar echoes force the question further. Is Mars still alive? Not in the way Earth is alive, with forests and oceans and weather patterns that dance with each season, but alive in the deeper sense, geologically active, climatically restless, perhaps biologically persistent. To detect changes this young is to glimpse a pulse, a faint heartbeat in the silence of a planet thought long dead. Scientists weigh the possibilities. Some argue that obliquity cycles alone, the tilt and wobble of Mars's axis, can explain the shifting layers. As the tilt grows steep, polar ice sublimates and frost migrates to lower latitudes. As it lessens, ice returns to the poles. Such cycles could create the stratigraphy beneath Utopia Planitia. Yet even if this explanation holds, it points to a Mars that is far more dynamic than once accepted, a planet that is still sculpted by its own celestial dance. Others speculate that groundwater may have played a role. Brines moving upward, freezing and thawing with each cycle, leaving behind deposits of salts and sediments. The suggestion is daring, for it implies not only climate change, but the persistence of liquid beneath the surface in epochs uncomfortably close to our own. The deeper scientists look, the more the dichotomy of Mars, dead or alive, unfolds apart. The truth may lie between a world neither entirely extinguished nor fully vibrant, but suspended in a state of fragile persistence. Perhaps that is what makes the mystery so unsettling. Mars cannot be neatly categorized. It refuses to tell a simple story. For those who dream of life beyond Earth, the implications resound like a drumbeat. If Mars carried water into the recent past, then microbial life may not only have existed but endured. And if it endured, then Mars becomes more than a subject of study. It becomes a parallel story of biology, one that could redefine humanity's place in the cosmos. The escalation is clear. A discovery once meant to chart dunes and sediments has instead reopened the most haunting of questions. Is Mars truly dead, or has it been whispering all along beneath its crust? The silence of Utopia Planitia offers no direct answer. Yet within that silence, Zhurong uncovered layers that tell of restlessness, of change, of possibility. The rover may now stand frozen, dust coating its solar panels, circuits silent in the cold. But its message echoes louder than ever. Mars is not what it seemed. It is not a fossil locked in deep time. It is a planet that may still carry within it the shadows of vitality. And in that shadow lies both the promise of discovery and the burden of responsibility. For if Mars still carries a heartbeat, however faint, then every step humanity takes upon its soil will not only be a step into the future. It will be a step into a mystery that has never truly ended. The echoes beneath Utopia Planitia did more than reveal layers of sand and stone. They opened the door to questions that stretch across science, imagination, and philosophy. What forces shaped these buried structures? What processes kept Mars alive in ways no one expected? And most haunting of all, what might still endure in the silence beneath its crust? One of the leading ideas begins with a simple truth. Mars wobbles. Unlike Earth, stabilized by its large moon, Mars is vulnerable to the gravitational tug of its neighbors. Over hundreds of thousands to millions of years, its axial tilt, its obliquity, can swing violently. At times it leans nearly upright. At other times it tilts steeply, exposing poles to sunlight and driving ice into new latitudes. Each swing reshapes the planet's climate. Polar caps retreat. Frost spreads across the equator. Dust storms grow fierce, redistributing sediments. In these great swings, water migrates, sublimating from one region, condensing in another, and sometimes pooling, however briefly, in shallow basins. Zhurong's layered radar echoes may be the fingerprints of these cycles. Strata laid down as dunes shifted, as ice migrated, as climates oscillated between harsh extremes. If true, the buried record at Utopia Planitia is not random. It is the diary of a planet whose climate has breathed in long, slow rhythms, inhales of ice, exhales of dust, echoing through the most recent chapters of Martian time. Yet obliquity alone may not be enough. Other theories reach deeper into the unseen aquifers of Mars. Radar data from orbit has hinted at bright reflections beneath the southern pole, signals that some interpret as briny water lakes locked beneath layers of ice. Though controversial, such findings raise the possibility that subsurface reservoirs may still exist. Brines enriched with salts can remain liquid at temperatures far below freezing, persisting where pure water would solidify. If such aquifers exist, they could have nourished cycles of freezing and thawing, producing the layered structures Zhurong now uncovers. On Earth, extremophiles thrive in similar environments. Bacteria cling to the brine channels within Antarctic ice, metabolizing slowly in the cold dark. Others inhabit the depths of subglacial lakes, sealed away for millions of years beneath kilometers of ice. Life adapts not through abundance but through persistence. Could Mars too harbor such survivors, not flourishing on the surface but waiting in silence beneath? Another theory is more dramatic, that Mars has not simply declined in a straight line, but has cycled through collapses and partial regenerations of its atmosphere. Some models suggest that volcanic outgassing in younger epochs could have thickened the air temporarily, producing brief interludes of warmth and pressure sufficient for liquid water to flow. Over time, the atmosphere would again thin, leaving behind sediments that bear the marks of water's touch. If so, then the planet has not only endured shifts in obliquity, but episodes of atmospheric renewal and loss. Each collapse would seem final, yet each regeneration would briefly allow Mars to breathe again. To grasp this possibility, one need only look at Earth's own history. Our planet has plunged into ice ages, when glaciers stretched nearly to the equator, and emerged again through cycles of orbital change, greenhouse gases, and volcanic activity. Earth has proven resilient, carrying life through extremes that once seemed unsurvivable. Mars may be a mirror of this story, a harsher, thinner, colder reflection, but not entirely unlike it. Where Earth's ice ages left valleys carved by glaciers and sediments rich with fossils, Mars's cycles may have left dunes reworked, salts crystallized, and brines preserved. The comparison is haunting. For if Earth with its oceans and atmosphere nearly froze into silence, then Mars with its fragile climate may have balanced precariously on the edge of survival. And in that fragile balance may lie the conditions for persistence, if not flourishing. Speculation deepens when the question turns to life. If microbes ever arose on Mars, they may not need oceans or rivers to endure. They may need only persistence. A few meters of dust to shield them from radiation. A pocket of brine to sustain their chemistry. A mineral surface rich with perchlorates or sulfates to feed their metabolism. Such organisms, if they exist, would not reveal themselves easily. They would wait, slow, dormant, patient beyond the scale of human time. The idea unsettles because it reframes what life requires. Oceans and thick atmospheres may not be the only cradles. Life might also find sanctuary in hidden pockets, in places that seem barren to our eyes but fertile in their own quiet way. If so, then Zhurong's discovery is more than geological. It is philosophical. It suggests that habitability is not a binary, not alive or dead, but a spectrum of persistence. The tension lies in what this means for humanity. If Mars still holds even the possibility of life, then exploration becomes more than curiosity. It becomes responsibility. To search is to risk contamination. To step upon the sands is to risk disturbing the silence that has endured for hundreds of millennia. Yet to turn away is to leave unanswered one of the most profound questions in science. Are we alone? In the layered echoes beneath Utopia Planitia, humanity glimpses not only the cycles of a planet, but the resilience of possibility itself. Mars, once thought static, may have written a story of change in its very soil. Each layer a line of speculation. Each signal a question cast into the unknown. Obliquity cycles, frozen brines, atmospheric collapses, comparisons to Earth's ice ages. All are pieces of a puzzle whose image is not yet clear. But the possibility lingers that beneath the sands, in pockets shielded from radiation and preserved by salt, life may not have ended. It may only have retreated, waiting for the next cycle, waiting for discovery. And so the speculation expands into philosophy. What if life does not demand abundance, but endures through persistence? What if Zhurong's echoes are not only signals of geology, but the faint shadows of biology? What if the truth is that life does not need oceans, only time, patience, and a hidden place to endure? The red planet remains silent, but in its silence it speaks. And what it whispers is a reminder that the universe is not bound by our expectations. Life may not always need fertile ground. Sometimes it may only need persistence in the shadows. Every revelation on Mars begins not with imagination, but with tools. Machines built by human hands, carried across millions of kilometers of interplanetary space, and placed gently on alien soil. Zhurong's radar was one of these tools. A quiet pioneer that opened a new dimension of exploration by peering beneath the surface. Yet it is not alone. Around Mars today and in the near future, a fleet of instruments continues to search, drill, and listen.
Each designed to carry the story further. On the other side of the planet,
Perseverance roams the floor of Jezero crater. Its wheels press into an ancient delta, a place where a river once fanned out into a lake that may have lasted for millions of years. Unlike Zhurong, Perseverance does not carry ground-penetrating radar. Instead, it drills into rock, extracting cores no thicker than a finger, carefully sealed in tubes. These samples are more than fragments of stone. They are time capsules, each preserving the chemical whispers of water, minerals, and perhaps even the building blocks of life. For now, Perseverance holds them in its care. But one day, perhaps within the next decade, they will be carried back to Earth. In laboratories across the world, scientists will search them for organics, isotopes, and the subtle fingerprints of biology. This mission, the Mars Sample Return, will be unlike any before it. A collaboration between NASA and the European Space Agency, it promises to bring Mars itself into human hands for the first time. The implications are immense. For if Zhurong's radar has uncovered evidence of recent climate activity, then the samples from Jezero may confirm whether Mars has indeed cycled through habitability more recently than thought. Together, they could rewrite the chronology of the red planet's potential for life. Europe, too, prepares its own explorer, the ExoMars rover, Rosalind Franklin. Delayed but still destined for flight, its design carries something even Perseverance lacks: a drill capable of reaching 2 meters below the surface. While most rovers scratch only the top few centimeters of dust and rock, Rosalind Franklin will search in the sheltered layers beneath, where radiation is weaker and the chemistry of ancient Mars may be preserved. It is a mission born of patience, but when it finally arrives, it will extend the reach of exploration into depths that have remained untouched for billions of years. What Zhurong proved is that the shallow subsurface is not barren. Its radar showed that even a few meters down, Mars keeps a layered memory of its shifting climate. The significance of this breakthrough cannot be overstated. For decades, rovers and landers studied only the surface. Cameras saw dunes and valleys. Drills tasted rocks at shallow depths. But all of it remained confined to what lay above ground. Radar broke that boundary. It bypassed the limits of touch and reached into the unseen world below. This change in perspective is profound. On Earth, geologists understand landscapes by reading both the surface and the subsurface. They drill cores, map layers, and reconstruct the deep past. On Mars, such tools have been scarce. With radar, the planet itself begins to reveal its buried structure, its hidden history. It is as if the desert has begun to speak in echoes, telling of cycles, waters, and times when the climate stirred. The next generation of tools aims to go deeper still. Ice-penetrating radars, refined beyond Zhurong's design, could map glaciers buried beneath dust across the mid-latitudes. They could trace reservoirs, measure thickness, and identify the chemistry of salts that preserve brines. Cryobots, robotic probes designed to melt through ice, are being imagined for the future. They could one day descend through frozen layers near the poles, seeking liquid reservoirs beneath. Drilling systems, more powerful than any yet carried to Mars, are being engineered to reach not only meters, but tens of meters into the crust. With each advance, the barrier between the surface and the subsurface weakens. Tianwen-1 itself, the orbiter that carried Zhurong, continues to circle Mars. Its cameras map the terrain, its instruments scan the atmosphere, and its data provide context for the rover's discoveries. Together, they represent China's first great step into deep space science, a demonstration that exploration of worlds beyond Earth is no longer the pursuit of one nation alone, but a shared endeavor of humanity. Zhurong may have fallen silent, its panels coated in dust, but its mission opened a pathway. Future Chinese missions are already in planning. Landers, orbiters, perhaps even sample return. Each will build upon the legacy of the small rover that rolled into Utopia Planitia and looked beneath the sands. The tools of Mars exploration are not merely mechanical, they are philosophical. Each carries the weight of questions older than civilization. Is life unique to Earth, or does it linger elsewhere? Are planets simple relics of geology, or are they dynamic, restless, capable of persistence? Mars is the testing ground, and the instruments humanity builds are the keys to its vault. The timeline is accelerating. Within years, Perseverance's samples may be launched into Martian orbit, captured, and ferried back to Earth. ExoMars may begin its drilling, reading what lies beneath the crust. NASA's orbiters, ESA's missions, and China's follow-ups may refine the subsurface radar maps, identifying not only where water once was, but where it may still be. Even the possibility of crewed missions now carries a new dimension. For human explorers will not only walk the deserts, but dig into the ice, melt the brines, and confront the question of habitability directly. The future tools extend beyond Mars. Technologies tested here, cryobots, radar drilling systems are prototypes for worlds beyond. For Europa, with its ocean sealed beneath ice. For Enceladus, where plumes erupt from a hidden sea. For Titan, where methane and water may mingle in alien chemistry. Mars is not only a destination, it is a rehearsal, and yet the deepest meaning belongs to the red planet itself. For centuries, Mars has been the canvas for our imagination, a place of canals, of dead civilizations, of lifeless deserts. Now with each tool, it becomes more complex. Each radar echo, each drill core, each sample strips away a layer of mystery while revealing another beneath it. Zhurong's role in this unfolding story is quiet but profound. It was not the largest rover, nor the longest lived. Yet in its short journey, it demonstrated that Mars is not static. That just beneath its surface lies evidence of change, activity, and perhaps persistence. Its radar is a bridge between what orbiters saw from afar and what drills may one day touch directly. It is the first word in a language Mars is only beginning to speak. In the decades to come, more tools will arrive. Machines will scan deeper, dig further, and even return pieces of Mars to Earth. Each will test Zhurong's whispers against the harsh clarity of laboratory science. Was the radar right? Were the layers evidence of ice, of brines, of water that lingered into the recent past? Or will new data reveal an even stranger story? For now, the answers remain buried. But with every tool humanity sends, the planet grows less silent. Each mission becomes a question pressed into the dust. And Mars replies not with words, but with layers, signals, and echoes. And in those echoes lies the greatest promise of all, that the story of Mars is still unfolding, and that with the right tools, humanity may finally read it in full. Mars has always been a mirror. To the ancients, it was the god of war, a wandering red star that bled across the night sky, a celestial omen of conflict and power. To modern science, it became the frontier of imagination, canals carved by the eye of hope, civilizations conjured in ink and stories, a world thought to be alive, then declared dead, and now, once again, balanced between the two. It is a planet both familiar and alien. Its days nearly match those of Earth. Its landscapes echo with mountains, valleys, and deserts that could almost belong to home. Yet its air is thin, its rivers gone, its silence unbroken by birdsong or wind in the trees. It is a paradox, a world that whispers of kinship even as it resists embrace. For centuries, humanity's fascination has endured. Mars has been a canvas for mythology, a stage for science fiction, and a destination for explorers of thought and machine. And in the age of spacecraft and rovers, the dream sharpened into reality. Each mission became a thread in a tapestry of discovery. Viking's first touch, Pathfinder's bounce across the dust. Spirit and opportunity, wandering farther than ever imagined. Curiosity, still climbing a mountain of time. Perseverance, caching the stones of a vanished river delta. And then Zhurong, a new voice in the chorus, carrying its radar into the heart of Utopia Planitia. What it revealed was not a world fixed in death, but a world layered with surprise. Subsurface echoes told of shifting dunes, migrating ice, and the possibility of water far younger than textbooks allowed. In that subtle signal lay a reminder that the universe is never finished. Even a planet long thought still may carry rhythms of change. Even a silence thought complete may hold within it the memory of a heartbeat. The image lingers, a small rover, solar panels outstretched like fragile wings, now dormant beneath a shroud of Martian dust. Its voice quiet, its circuits frozen in the cold, and yet in its silence it continues to speak. Every line of data it sent home is an echo of its final message, that Mars is not a grave, but a story still being written. This reflection reaches beyond Mars. It touches the nature of discovery itself. The universe does not yield its truths easily. It conceals them in layers of rock, in pulses of climate, in faint whispers beneath the noise of expectation. But when humanity listens, with radar, with drills, with patient imagination, the cosmos answers. Not with certainty, but with possibility. Mars, in its silence, offers more than science. It offers humility. It reminds humanity that certainty is fragile, that knowledge is provisional, and that even the nearest worlds still defy complete understanding. It is both dead and alive, barren and yet restless, alien and yet strangely familiar. It forces a recognition that categories fail, that life and death may not be opposites but parts of a spectrum written across the fabric of worlds. And so the story closes not with an end, but with a question. If Mars can change, if it can surprise us still, what else waits in the universe? What other worlds carry secrets beneath their surfaces, waiting for machines or perhaps one day people to uncover them? What else in the cosmos whispers that the unbelievable may yet be true? The camera drifts back away from Utopia Planitia. Dust swirls across the plains. The rover remains still, but its discovery lives on. Mars, once thought silent, has spoken again. And the message it leaves is both haunting and hopeful. If Mars can change, if it can surprise us still, what else in the universe waits to reveal the unbelievable?